All right, this is our last section for Unit 3, 3.6, and we're focusing our attention now to polynomial inequalities. I'm going to cover two examples in this video, one where we're using the graph of a polynomial function to solve an inequality, and then another where we're using a sign analysis, okay? So example 1, let's solve the inequality x cubed is less than or equal to 4x squared by sketching the graph. So we're looking for all values of x that satisfy this, this inequality, okay? So first thing we're going to do is move everything to one side. So I'm gonna move it all to the left, and I'm now working with x cubed minus 4x squared is less than or equal to 0, okay? And I'm going to treat the left side now as a function, okay? I'm going to treat it as f of x, and I'm going to graph that function, okay? It is going to have an in behavior as follows. As x approaches infinity, f of x will be approaching infinity. And as x approaches negative infinity, f of x will be approaching negative infinity. That's based on degree being odd, leading coefficient being 1, right? Your y-intercept would be f of 0, which equals 0 in this case. And then for your x-intercepts, you're going to need to set the function equal to 0 and solve that. Luckily, this one's not too bad. I can factor here. Factor out an x squared. I'll end up with x equals 0, where the multiplicity is 2, and x equals 4, where the multiplicity is 1. Okay, so let's sketch this out. Just make a quick little x and y axis here. It doesn't have to be super pretty. Okay, so we only have 2 points to go off of. Right here is both an x and a y-intercept, and then right here is our other x-intercept, okay? So then based on in behavior and multiplicity, the curve's going to be doing something like this. We're going to come up, we got to touch that and turn back around based on the even multiplicity, then turn around again and finish high. Okay? So now we can use the picture, this graph, to see what the solutions to f of x is less than 0 are. By moving everything to one side of the equation, we have effectively now thought of this inequality as when is f of x less than or equal to 0? So graphically, that means when is the curve on or below the x-axis, right? When you're on the x-axis, your y value is equal to 0. When you're below the x-axis, your y value is less than 0, okay? So we can see that that is happening on the interval negative infinity all the way up to 4. Negative infinity to 4. So you could write it like that, or of course you could say x is less than or equal to 4. There's your solution. Okay. Now, your second way of doing this is with a sign analysis. And this is kind of the method I prefer because I think it's a little bit quicker. And recall we used a sign analysis to solve quadratic inequalities last unit, so hopefully this will go pretty smoothly for you, okay? So now we're solving the inequality x cubed is less than or equal to 9x using the sign analysis. So just like the previous problem, I'm still going to move everything to one side. And I'm going to treat the left side like a function. So let f of x equal x cubed minus 9x. And I'll find the zeros, meaning the x-intercepts. I don't really have to find the y-intercepts here. So I can factor an x out, and then I'll factor further, x plus 3, x minus 3. So my zeros are x equals 0, 3, and negative 3, all of which have a multiplicity of 1. Okay, so I'm going to make a number line to represent just the x-axis. And I'm going to place those numbers on the line. Okay. And now that those three numbers are dividing the number line into 4 intervals, I'm going to pick a number from each interval, within each interval for x, to plug into the function and get a y value for. Okay. And I don't really care about the value for y, I only care about the sign of that value. Okay. So when I plug in -4 for f, I'd actually plug it in to the factored form. I would plug it in right here. And the reason I do that is because if all I care about is the sign, I can pretty easily tell what that sign is going to be using the factored form, right? So like if I plug -4 in for x, that's going to be negative. And then I plug it into x plus 3. So -4 plus 3 would be negative as well. And then I plug -4 into -4 minus 3, that's going to be negative as well. So 3 negatives multiply to give you a negative. Okay, so I'll put that right here. If I were to plug -1 in for f, -1 is in the second interval between -3 and 0. Okay, that's going to give me a negative times a positive times another negative, which will result in a positive. Okay. In the third interval, I'm choosing 1 to plug in. That's between 0 and 3. That'll give me a positive number times another positive number times a negative number, which results in a negative. Put that back in. And then in the final interval, anything larger than 3, notice I'm choosing 4. That's going to give me a positive times a positive times a positive using the factored form, and that will result in a positive. Okay. Now that you have the sign analysis, you can kind of come up with a quick little sketch to the curve here. Minus in the first interval means the curve is below the x-axis. Plus in the second interval means it's above, then below again, then finishes off above. So I can tell you the curve's doing something like this. Okay. And now I use the sign analysis, or you can use the sketch that you just reasoned out to solve this inequality. When is f of x less than or equal to 0? Well, less than 0 means focus on the negative intervals, and then equal to 0 means focus on the zeros themselves. So I can essentially write my solution in 2 intervals. The first would be from -infinity up to -3, where -3 is included, and then combine that with the interval 0 to 3, where both 0 and 3 are included. Okay, so hopefully that one went pretty smoothly for you since we've done the sign analysis before. Okay, so now you're going to go to practice 1. You're going to try that one yourself. You get to pick which method you want to use, and pause the video as you work through that yourself, and then come back and check your work with mine.